this session is really focused on what we're aiming to do for films. And we talked a little bit about Octane and Brigade. Those are two core GPU rendering technologies that run on the cloud, and also, of course, on GPUs that are on your own machine. But what this session is designed to do is sort of illustrate how the film industry is changing because of these technologies. And it's a pretty seismic shift, and it's a pretty recent one. Last year at GTC, Jensen invited us on stage, and we showed really sort of, I guess, the first stage of how we imagine GPUs changing the way the films are made. In addition to being able to render an order of magnitude faster, probably an order of magnitude at better quality, because you're basically doing the full physics and lighting for a film on a GPU that you couldn't do on a CPU. Caustics and the way the light bounces is typically truncated for CPU rendering. Not so with Octane on a GPU. And a year later, Fantastic Four, which is the movie that we were working on with Josh, the director, is now going into production, and we've had a really amazing year sort of seeing Octane evolve from those very first steps that we took introducing it to the world and of filmmaking last year to today. We asked a number of our users to, especially in the film business, to provide a couple of insights into their experience with Octane from a perspective relative to how their CPU pipelines used to work. And you can see here Steve Messing, who's worked on a number of amazing films from Star Trek to Godzilla, provides a really wonderful endorsement of Octane. And it's I think that a lot of people last year looked at what we were doing with Fantastic Four and wondered, is this a one-off, or is this really going to take off? And I think that our experience has been we don't even know all the different films that are using Octane right now. I mean, we just learned about it was used for Godzilla just last night, and if we're lucky, maybe Mothra and Rodan will be rendered in Octane, which would be great. But it's very clear to us that this is something that's going to replace CPU rendering, and we want to do that as quickly as possible so that the costs go down, movies get better, and artists essentially can see what they're doing in real time. This is not just something that affects the big studios. It's also a huge win for smaller filmmakers and studios, especially individuals that don't have a huge budget or that aren't even looking to the cloud. One of the things that we've seen is that Octane has provided even students with a laptop the ability to render final quality frames that would have taken hours, essentially in minutes. And that is something that is really providing we have about 80,000 members in the Octane community, and a lot of them are students. In fact, because of that disproportionate ratio, we've offered Octane free to students so that they can sort of learn the tools and start building a career around this technology. This is an interesting short that shows the stuff that we're typically seeing from amateur and student users, and also small independent houses, and it looks great. I mean, it looks absolutely flawless. And typically, a CPU renderer that was the only available option in the past would have been really out of reach for animated content like this. But these are shorts, right? I mean, the thing that we really wanted to see in the 12 months since we announced this Octane for films with 20th Century Fox is, can we do an entire movie with final frame rendering done on GPUs? And the answer is yes. And we have our first milestone where that's been achieved. And it was really a very recent film called Space Station 76. Variety just gave it glowing reviews just a week ago. And Billy, are you in the audience? There you are. Billy is the artist that took Octane in and developed and gave us feedback on all sorts of things, but essentially used Octane for every shot of the movie. Am I right? And if you don't mind, I mean, I'd love to hear your feedback or thoughts on your experience, and we can,
Is this on? Okay. I was. I worked at ILM for 7 years, and I was at EA for 5 years, and DreamWorks for 3 years. So I've had experience at the big studios, and this is the first time that I took on a whole movie. Had about 470 shots, and I did most of these effects out of my bedroom. And it turned out so well that we actually fooled the Hollywood Reporter into thinking we used physical models for our visual effects, which is a huge thing for a visual effects artist. But I was telling Jules that Octane allows artists to be artists again, where it's like the technology's always been the bottleneck to sort of gum up the works, but it seems like we're experiencing the future, and I think that he actually is in the future, has come back somehow to give us technology from the future. But I had so much fun being an artist again, working on this movie and using Octane, and it was a pleasure, and I thank you so much.
Thank you, Billy. That's an amazing endorsement, and it's inspiring for us to hear these kinds of experiences with this technology. And I mean, we built this technology in order to really provide this kind of transformative workflow. So we're not done, though. I mean, we've come a long way in a year, but this year is really an important one for us, and there's a lot that we've been working on, and some of that we announced at SIGGRAPH last year. We had the 1.0 version about a year ago when we were showing it at GTC last year, and then we announced 1.5, which was really a lot of critical features that we felt we needed for production rendering to be viable. And interestingly enough, I mean, this is something we just released, so this is now just entering into the Octane community. But 1.5 really enables us to take on animation in a more efficient way. So we support things like a Limbic, which is an industry standard for animation data, and the feature set that we have now enables us to do much more complex UV layering, visibility groups. We've enabled a very comprehensive scripting API so that the Octane community can add and build on top of the things that we do. And I think one of the most hidden but powerful features is the Orbex file format. And this is a packaging format. It's like a zip file, but you can import and export anything in this format that is inside of an Octane plugin. And there's Octane plugins for every app at this point. I mean, we've done all the Autodesk applications, Blender, Cinema 4D, and you can take a scene that's created in one of these apps and bring it into another one. And that interchange has not really been viable with a physically correct lighting pipeline until Octane delivered this. And we also use the Orbex file format to transfer data to Amazon for final rendering. And there's other uses that we're envisioning for this, anything from 3D printing to storing physically scanned material data. So those things are in 1.5. It's only been out a week, but it's already, I think, a huge shift in terms of getting Octane to be where we want it to be for film work. And so that sort of leads us to where we're going for the rest of the year. We've got 9 months left in the year, and we've got an incredibly ambitious roadmap. And we're going to be going through that today. We're going to be announcing the next version of Octane, which is Octane 2.0. We've had, ever since we announced Octane 1.5, everyone's sort of given us a wish list of features that are, they'd be easy to do in a CPU render. They're very difficult to do in a GPU render. The magic of Octane, the reason why it's so fast, is that we have to recreate everything that's been done for decades of rendering and figure out how to do it in parallel on a GPU. And that gives us that speed. I think Octane was a small miracle in the beginning when it just was able to have this incredible lighting quality. But as we look at filling every single checklist that an ILM or a film production uses, it gets incredibly complicated. But Octane 2, we're confident, is going to nail every one of those. The first and foremost feature that I think is salient is displacement mapping. Displacement mapping essentially means you can take a texture, you can put it on an object, and the surface of that object follows the depth of that texture. It's something that we added very carefully to Octane. The texture, the fact that that we can use textures to now create this complex geometry, like what you see on the right versus the left, solves one of the major issues with GPU rendering, which is that we don't have a lot of memory. I mean, GPUs typically have about 1/10 the memory of what you could get on a CPU. But with displacement mapping, a lot of that can be simplified, and you can just have one single texture that creates this incredible amount of detail. And displacement mapping is probably the #1 feature that people have been asking for since last year. The other new feature in 2.0 is object motion blur. This is a key thing, a key element of a film rendering. 24 frames a second, you have to have motion blur. 1.5 had camera motion blur, 2.0 has object motion blur, and by the time that we are at the end of this year, we will have, the holy grail of motion blur in films, which is deformable object motion blur. That's, I don't think, in any GPU render at this quality. So that's a huge win. And of course, all this is still running 100% on the GPU, and we're really not looking backwards to do anything on the CPU. It's something that is, it gives us our edge, and it gives us the ability to scale, whether it's on a single computer or one of the VCA appliances that NVIDIA just announced today, or on Amazon. It gives us this ability to scale and deliver an order of magnitude better quality and speed. The third major feature in 2.0 is hair and fur primitives. We had artists that actually could build hair models, but it was insane. It was a huge amount of memory. It was really complicated. So Octane natively now supports hair and fur, and that is also a gateway to supporting other things. We can support splines, we can support spheres, particles. Previously, and typically of other renderers, you turn everything into tiny triangles, and that's not efficient. So now we have strands, and we can now add any sort of procedural geometry in the future on top of this framework. But 2.0 will sort of open that feature set with hair and fur. And then there is a whole laundry list of things that we queried our users about as to what they would want to see in Octane. And we decided, we told them to pick 3, and those are the 3 that we just showed you. But we ended up implementing all of them in 2.0. So there's a lot of great stuff in here. There's Pixar open subdivision surfaces, right? This allows you to tessellate geometry dynamically so that you don't have to use huge amounts of GPU memory for really complex curved surfaces. Rounded edge rendering, which is critical for the intersection of eyes and eyelashes, right, where you have a water barrier. That's stuff that is impossible to render correctly without this feature. Render region rendering, which is a requested feature that allows you to focus on a specific part of a frame and give it more rendering power. And network rendering, which allows you to take all the computers on your LAN and use all the GPUs in unison. A new sky system that allows you to combine HDRI and sun, which was difficult to do in Octane without losing any speed, and we've managed to do that without any drop in performance. And there's more. We have randomized colors for each instance that allow you to do really complex vegetation or massive crowd simulations. These, again, are things that are probably very high-end features in production renders. They have to be in Octane. It was on our to-do list for a while. We're also expanding LiveDB to allow you to store your own custom libraries. And then there's a lot of modes that we're adding beyond just traditional 2D frames. We have stereo rendering. We're also supporting light field rendering, which we think is going to be important as new display types come out that support planoptic and light field displays. In fact, NVIDIA is showing such a display at GTC, and it's going to be a requirement in the future for planoptic rendering to deliver the kind of realism that the human eye expects to see. And then sort of the last type of rendering that we're enabling is basically VR rendering, right? Where if you want to create a movie for the Oculus Rift, which I guess now is going to be the Facebook Oculus Rift, which is crazy, or Sony's new HMD or Valve's HMD. These are all really different takes on the same issue, which is how do you send the light rays from a render into the human eye at the most, the greatest efficiency. And we need to be able to render curved surfaces. We want to be able to render the detail that goes into the pupil at with higher precision than the surrounding peripheral areas. And Octane 2.0 does that. As far as pricing and upgrades go, the upgrade from 1.x to 2 is going to be 99 euros. The final price will go from 199 to 299. It's still incredibly cheap, considering that a lot of production renderers are 10x that or 20x that. And for that upgrade price, you also get to upgrade any of the existing 1.x plugins that you may have bought to 2.0 as well. We mentioned earlier that students are a big part of our community, and we do have a free version of Octane that is, as of today, available to students with an EDU address. And we're going to essentially extend that to Octane 1.5 once 2.0 is released. And if students want to really move up to 2.0 and get this really high-end production rendering, they'll be able to have an option that allows them to do that for under $10 a month. And I think that that's the cost of a hamburger, right? So I think that any student that is really interested in moving beyond the free student version is going to have the ability to get Octane for really something that's an incredibly affordable price. And we're not going to limit that to students. Anybody that is interested in that rental model will be able to leverage that. We're also, we've also been very aggressive with getting the entire ecosystem ready for 2.0. All the plugin developers have had the 2.0 SDK for a while. They've kept mum about it and kept our secret until today, which is great. But you can expect to see the 2.0 plugins pretty much released in unison with the standalone. So we're looking at releasing the 2.0 standalone with the major first-party plugins and most of the third-party plugins this summer. So that's going to be an important midpoint for us this year. But there's more. And when we announced Octane, we actually had a pretty comprehensive roadmap that took us 4 versions to get through, right? 1.0, 1.1, 1.2, 1.5. And we envisioned a couple of steps to really completing the second version of Octane. Everything you just saw is shipping in 2.0. So that's going to be available this summer. But by the end of the year, we want to really add even more things. And those are things that really extend Octane outside of the core rendering features we just showed into other areas. The goal is that by the end of the year, with a full set of features that we've added to Octane 2, you can say goodbye to CPU rendering and move to GPU rendering. So the features that we're adding include deformable motion blur, out-of-core textures, right, so that you can use system memory, GPU-defined procedurals, and very significantly, a full compositing pipeline around Octane 2 that covers all sorts of rendering passes, multi-layer EXR output, deep compositing. You can see in here we're showing all the different layers that you can do in the render passes. Actually, it's not all. There's actually about 22, so this is just about a third of that. But there's a really important reason why we've added these render layers, and that is so that we can create a complete and full integrated bridge to Adobe Creative Cloud. So that means that all those render passes that you saw will work inside of Adobe Photoshop, Adobe After Effects, with integrated plugins that are really pretty awesome. So this is the Photoshop one that is giving you a live viewport within Photoshop. You paint in the Photoshop canvas. Octane updates the texture in real time. And I think this one is a pretty cool one. This is showing After Effects with an integrated OctaneRender plugin. And every single aspect of Octane is fully exposed as a layer in After Effects. With Alembic support, everything that you've just seen in 2.0 is now essentially built into After Effects. This is something that I think is going to really significantly improve the efficiency of Octane and for final renders and compositing. We're not done yet. I know we only have a few minutes, so I'm going to try to get through this quickly. The next step for Octane is to merge it with Brigade, our game renderer. We want to have a common physically correct rendering pipeline that allows you to target either real-time games in the cloud or final render, not have to redo that artwork, not have to think differently for doing games versus movies. So to that end, Orbex, the packaging system for Octane, goes directly into Brigade on Amazon, and you can start building games with it second half of this year. Octane and Brigade share the same materials, shaders, and that's a first. There's really never been a single pipeline for doing games and films that look identical, but we have that, and it's really largely thanks to Amazon and NVIDIA GPUs that we can deliver this year. So these are renders from Brigade, and I'm going to close by just showing a short video that is showing Brigade running on, I guess, 2 Titans. We've never shown this before. This is basically Brigade with the Octane lighting and material system running on 2 Titans, noise-free, and this is really cool. I mean, this is basically final cinema quality rendering that is fully interactive at 60 hertz. Outdoor scenes, and this is not complete. This is still, a couple of iterations away from the final version, but this is already noise-free for outdoor scenes, full path tracing. Indoor scenes, we're close enough now where we can do filtering to get rid of the noise, and that's kind of the last step. But these are all scenes that are exported from Octane, rendering in Brigade that could be used to deliver game experiences, walkthroughs, all sorts of things that are sort of outside of the final rendering focus that Octane has had. Again, physically based lighting allows you to just create all sorts of awesome experiences, and there's no hacks necessary. This is showing 600 point lights, which is incredibly difficult to do in real time with a ray tracer or path tracer, but Brigade is pulling that off. And these features can also be migrated back into Octane. We are going to blend these things together as we go through this year. But obviously with Brigade, the focus is on real-time. Octane, the focus is on final render film quality. This is also, I mean, you can see the physically correct sky system from Octane is in Brigade. I think the next set of features are interesting. This is for HMDs, right, where you want to render 180 degrees with Fovea Rendering, and this is doing that in Brigade. We also support reprojection locally, so that allows you to render this complex lighting in the cloud and then deliver that with zero latency to devices like the Rift or the Sony Morpheus HMD device. And there's a number of features in Brigade that I think are even improvements on what we do in Octane, such as volumetric God rays and things like that that are obviously incredibly fast, motion blur, and also some very complex lens effects. But this is something that, when it's released, I think is going to change the way that gaming is done. I mean, we're replacing DirectX and OpenGL with this, and I think people are never going to look back. So that's it. I don't know if we have time for any questions. If not, you can ping me later.